Okay, so I left the last video promising you that I would show you how to find um, greatest common factor of a trinomial. So 5x squared plus 20x plus 15. Okay, so there's a trinomial. Remember, finding the greatest common factor is pretty much I want to find a number that I can undistribute. I want to undistribute a number. The fact that 5 right here is a prime number tells me that if I'm going to have a common factor, it's going to have to be 5 because that's the only thing that this can factor out is going to be a 5. So I'm going to quickly see that this is 5 times 1, this is 5 times 4, and this is 5 times 3. So I've real quickly shown that 5 is the common factor, and it has to be the greatest one because it's the only thing left for, it's the only factor other than 1 for this first term right here. So undistribute that 5. That leaves, if I factor out that 5 right there, that's going to leave a 1x squared. You can put the ninja 1 if you want to, but you don't have to. Plus, it's going to leave me 4x, and then it's going to leave me plus 3. Okay, so factoring out your GCF is always going to be step number 1. Then the next question you're going to need to pay attention to is how many terms am I dealing with? Do I have 2 terms? Do I have 3 terms? Or do I have 4 terms? And depending on what the answer to that is, it's going to help you decide how you continue this problem. Okay, so let's deal with having just 2 terms. Okay, so let's start with step number 1. This is an example. And the problem that I'm going to give you is x squared minus 25. Okay, so this one right here, it says check for a greatest common factor. Does this have a greatest common factor? No, it does not, because the only factors of this are x and x. The only factors of this are 5 and 5. They don't have anything in common, so the answer is no. Now the question is, how many terms does it have? It has 2 terms. So I'm down here to this part of the flowchart. It has 2 terms. Is it then a difference of 2 squares? So you have to understand that what the question is. Is it a, and I am not going to write down difference of 2 squares every time I'm going to write down dots. So it's a difference, all right? The word difference is having to do with that minus sign. So yes, this one is a difference, okay? It's going to be of 2 things right here because there's 2 terms. So the difference of 2, so we've got every one of these, difference of 2, so far we meet those criteria, but are these 2 things that we're looking at right here, are they perfect squares? So, F-E-C, perfect squares. So let's make sure you know what I'm talking about when I say what a perfect square is. Okay, 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. 4 times 4 equals 16. 5 times 5, I hope you know what I'm doing. 36, 49, 7, 8, 64, 81, 100, 121, 169. I think I can even go further. 196, and this is 225. So 5, 6, this is 6 squared, this is 7 squared, 8 squared, 9 squared, 10 squared, 11 squared. Oh, I forgot 144. Goodness. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. This list that I just made, that list is a list of perfect squares. Okay? Now, since this list is created by multiplying something times itself, we've got x squared. We've got x to the 4th. Has to be a number that's multiplying times itself. So these right here are also perfect squares. They're perfect squares that are variables, but they are perfect squares because x times x is x squared times x squared is x to the 4th, x cubed times x cubed is x to the 6th. So my question is then, again, is this the difference, a subtraction problem, of two terms that are both perfect squares? So the answer is yes. How is the answer yes? Because x squared is on the list. This one's on the list. And this number is on the list. Now, is that a complete list? Absolutely not. Should you have a complete list? Yes, you should. Well, I mean, you can't have a complete list because numbers go to infinity. But you should be able to quickly see, these are the ones that we're probably going to use most often. But, you know, recognize, I don't know, let's say 400. 400, is that a perfect square? Yes, because that's 20 times 20. So, and if you don't know how to determine it, then you should be able to go to a Desmos calculator. Let me clear that off. And be able to say, you use this button right here, the square root button, and say 400. And if it gives you a number without a decimal, then it's a perfect square. Square root of 25. You see how it gave me a number without a decimal? Square root of 9. See how it gave me an answer that doesn't have a decimal? Square root of 8. 8 is not a perfect square. Why? I got all of these decimals. So you can check numbers to see if they're perfect squares. You can't check x's, but it's pretty easy. If x is an even number, then it's going to be a perfect square. 2, 4, 6, 8, 10, 12. If the exponent is an even number, then it's going to be a perfect square. All right, so now that we've determined that it is a dots problem, or a difference of two squares, then if the answer was no, then actually, for our purposes, this right here doesn't happen until after Christmas. We won't do this until after Christmas. So maybe I shouldn't put an X through it. Let's just go right here, and we're going to say, let's say stop right here. Okay, so we don't do this. We'll save this right here for after Christmas. Okay, but if it's the difference of two squares, then if it's not the difference of two squares, then you just stop. Okay, you've done everything you can do. It's factored completely. If it is the difference of two squares, then here's how it factors every time. You take the root, and remember, these right here are roots. 1 times 1 gives you 1. These are roots. This is the perfect square. 2 times 2, 2 is the root. 4 is the perfect square. The root right here is 3. 3 is the root, 4 is the root, 5 is the root, 25 is the square. You with me? So you take the roots of the first term, go in each parentheses first. You put a plus sign and you put a minus sign every time, a plus sign and a minus sign, okay? And then you take the roots of this second one and you put them here. And that's the way it factors every time. You should always, it doesn't say here, but we should always check. Okay? And how do we check? You check by multiplying. You check by doing a box. You check by however it is you multiply. X plus 5, X minus 5. Okay, you build a box and you get X squared, you get 5X, you get minus 5X, and then you get negative 25. These two right here are going to add to 0. Positive 5x and negative 5x, they add to 0, so your answer is x squared minus 25. And that's the way it's going to work every time. If it's a difference of two squares problem, it's going to factor like that. So I'm going to ask you to do a couple more. Difference of two squares. Let's try that, and I'm going to stop the video and we'll start the next video with you having worked those. So try that one, try that one, and try that one. All of those are difference of two squares. Problem 1, problem 2, problem 3. See if you can get those factored.